structures. And the stones are immense, and some of them were cut from a quarry that's hundreds of miles away. How do you think they did that?
For a very long time, the construction of Egypt's first pyramid baffled historians and archaeologists alike.
If it's going to carry blocks right up to you're looking, no gang of workers can haul a 20-ton block.
How did an ancient civilization without modern tools create such monumental structures with unmatched precision? Recent breakthroughs powered by AI analysis of archaeological data have shed new light on this mystery, unveiling methods that challenge long-held beliefs. Far from relying on myths or speculation, this discovery reveals a fascinating, entirely practical approach that highlights the ingenuity of the ancient Egyptians. The role of AI in archaeological discovery. When it comes to peeling back the layers of ancient mysteries, technology has always played a vital role, from ground-penetrating radar to satellite imaging. But in recent years, artificial intelligence has taken things to a whole new level, becoming a game-changer for archaeologists. AI doesn't just scan ruins or snap photos, it helps sift through massive amounts of data with a speed and precision that humans alone can't match. Imagine trying to piece together a 4,500-year-old construction puzzle. The Step Pyramid of Djoser, built in the 27th century BCE, left behind plenty of clues: fragments of stones, remnants of ramps, ancient texts, and architectural plans inscribed on temple walls. The challenge? These clues are scattered, sometimes damaged, and hidden across a vast area. Researchers have spent decades combing through this information, but many questions remained frustratingly unanswered. Enter AI. By applying machine learning algorithms to archaeological data, scientists can now identify patterns that would be nearly impossible for humans to spot. For example, AI can analyze satellite imagery to detect subtle changes in the landscape, like the faint outlines of ancient ramps or paths used to transport heavy stones. It can process 3D scans of the pyramid and surrounding structures to reveal construction sequences and hidden architectural features. But the magic doesn't stop at visuals. AI also helps interpret ancient hieroglyphics and texts related to construction records and labor organization. Natural language processing techniques allow computers to read and contextualize these writings much faster and more accurately than traditional methods. One fascinating aspect of AI's role is its ability to simulate construction scenarios. By feeding data about the pyramid's size, materials, and geography into AI models, researchers can test different building methods virtually. This helps identify the most efficient techniques the ancient Egyptians might have used, based on physics, manpower, and available resources. This data-driven approach moves us beyond guesswork. Where earlier theories depended heavily on assumptions or modern analogies, AI grounds the conversation in measurable evidence. It can even challenge long-held ideas, such as the notion that massive straight ramps were the only way to lift giant stones, by revealing alternative techniques suggested by patterns in the data. In short, AI acts like a supercharged detective, piecing together disparate clues with incredible speed and accuracy. Its insights don't replace human expertise but amplify it, providing new directions for archaeologists to explore in the field. Thanks to AI, what once seemed like an insurmountable mystery is now becoming clear. The first pyramid's construction is not just a story of brute strength or luck. It's a story of clever design, resourceful engineering, and meticulous planning, revealed through the lens of modern technology. So, what exactly has AI uncovered about how the ancient Egyptians built their very first pyramid? Ancient secrets revealed. The revelations are nothing short of fascinating, overturning many old assumptions and revealing a level of ingenuity that's both practical and elegant. For decades, the dominant idea was pretty straightforward. The Egyptians used massive straight ramps to haul enormous limestone blocks up as the pyramid grew taller. These ramps were thought to be colossal earthworks, extending hundreds of meters, requiring immense manpower and materials. But the problem was simple logistics. How could such enormous ramps be built and dismantled efficiently? And where would all that dirt and stone come from without disrupting the construction site itself? AI's analysis of satellite images, ground scans, and architectural remains tells a very different story. Instead of relying on a single gigantic ramp, it appears the Egyptians used a complex system of multiple, smaller, and more strategically placed ramps that wrapped around the pyramid in a spiral or zigzag pattern. This design not only saved material, but also allowed teams to work simultaneously on different sections of the pyramid, speeding up the entire process. What's more, the AI found subtle wear patterns on the blocks themselves, indicating that the stones were often moved on sledges lubricated with water or a type of resin, reducing friction dramatically. This simple but effective method meant fewer workers were needed to drag the heavy stones. Experimental archaeology backed this up. Modern recreations showed that wetting sand in front of sledges reduced the force needed by almost half. AI helped confirm this by cross-referencing wear marks and environmental data. Another key insight involves the precise cutting and placement of stones. Previously, experts believed that fitting such large blocks perfectly required a trial-and-error approach that wasted time and resources. Instead, AI's 3D modeling of the Step Pyramid revealed a highly methodical process of quarrying and shaping each stone off-site, with markings that served as guides for assembly, much like a giant ancient jigsaw puzzle. This level of precision suggests the Egyptians had a surprisingly advanced understanding of geometry and measurement. AI also highlighted the use of lever systems and counterweights, seen in small-scale models and reliefs, as more than just artistic depictions. The data supports the idea that these tools were practical aids in lifting and placing stones, especially at higher levels of the pyramid. This challenges the earlier notion that brute force alone was responsible. Perhaps the most remarkable discovery comes from AI's reinterpretation of ancient texts and labor records. Far from being a chaotic, ad hoc workforce, the construction effort was incredibly well organized, with workers divided into specialized teams responsible for different tasks, from quarrying to transport, shaping, and assembly. The AI analyzed patterns in the distribution of worker camps, food supplies, and tools around the site, showing a sophisticated logistical network that ensured continuous workflow without major interruptions. All of this paints a picture of a civilization that wasn't just relying on manpower or simple engineering tricks. Instead, they applied smart problem-solving, efficient resource management, and innovative engineering, all backed by detailed planning and coordination. The AI-driven discoveries don't just fill gaps in our understanding. They offer a complete, coherent narrative of how the Step Pyramid was built. It was a combination of clever design, like the spiral ramps, practical tools, sledges, levers, lubrication, advanced craftsmanship, precise stone cutting, and social organization, teamwork, logistics, that made this monumental achievement possible. What makes this even more impressive is that these techniques laid the groundwork for future pyramids, influencing how Egypt's later, larger pyramids were constructed. The first pyramid wasn't just a one-off wonder, it was a blueprint for architectural evolution, all decoded thanks to the marriage of ancient ingenuity and modern AI. To fully appreciate how the first pyramid was built, we need to take a step back and understand the world the ancient Egyptians were living in at the time. The first story of the mighty pyramids. The Step Pyramid of Djoser constructed around 4,700 years ago during Egypt's Third Dynasty, marked a pivotal moment in human history. It wasn't just an architectural experiment, it was a symbol of a civilization's growing power, religious beliefs, and social organization. Before the Step Pyramid, Egyptian rulers were buried in what are called mastabas, flat-roofed rectangular tombs made of mud bricks. These were fairly simple structures, designed more for practical burial purposes than for grand display. But Pharaoh Djoser, who ruled from approximately 2670 to 2640 BCE, wanted something more impressive, something that would assert his divine status and secure his place in eternity. Enter Imhotep, the architect and vizier credited with designing the Step Pyramid. Imhotep was no ordinary builder. He was a polymath, a priest, healer, and engineer who transformed the traditional mastaba into a stacked, stepped structure rising to about 62 meters high. This was the world's first large-scale stone building and the earliest colossal monument built entirely of cut stone. This wasn't just a tomb, it was a statement. The Step Pyramid symbolized the pharaoh's journey to the afterlife and his connection to the gods, particularly the sun god Ra. Its design reflected Egyptian cosmology and religious ideals, representing a stairway to the heavens. But constructing such a groundbreaking monument posed massive challenges. Stone construction was a major leap from mud bricks, requiring new tools, materials, and techniques. Unlike earlier structures, the Step Pyramid demanded unprecedented levels of coordination, manpower, and resource management. Quarrying huge limestone blocks, transporting them across difficult terrain, shaping them precisely, and assembling them into a stable, towering structure was no small feat. Egypt at the time was a highly centralized state with growing bureaucratic capabilities. The pharaoh held absolute power, and a complex hierarchy of officials, priests, and laborers made large projects like the Step Pyramid possible. The Nile River played a crucial role as a transportation highway, allowing materials and workers to move efficiently. Despite its monumental scale, the Step Pyramid also marked the beginning of an architectural tradition that would evolve dramatically over the next few centuries. Later pyramids, like the smooth-sided Great Pyramid of Giza, built upon the innovations pioneered here. Understanding this historical backdrop is essential because it shows us the context in which the construction methods were developed. The Step Pyramid wasn't built in isolation. It emerged from a society with increasing technical knowledge, social complexity, and religious motivations. This foundation helps us see why uncovering the construction secrets isn't just about stones and ramps. It's about the people, beliefs, and systems that made this ancient wonder possible. Logistics behind building a massive physical wonder. Building a massive structure like the Step Pyramid was more than just an engineering challenge. It was a colossal logistical puzzle. Think about it. Moving thousands of heavy limestone blocks, some weighing several tons, without cranes or trucks. Organizing thousands of workers, ensuring a steady supply of food and tools, and doing all of this in the harsh Egyptian climate. How did they pull it off? First, let's talk about materials. The limestone used for the pyramid was quarried locally,
along with some of these white limestones to break loose. Unfortunately for us, the Egyptians at the time decided to then strip off the rest of the white limestone along with the capstones so they could be used to help rebuild the city.
Primarily from the nearby Tura and Maadi quarries. These stones were prized for their fine quality and smooth finish, perfect for the pyramid's outer casing. Transporting these blocks from the quarry to the construction site was a significant challenge. The Nile River was essential here. During the flood season, boats could ferry large stones close to the site, greatly reducing overland hauling distances. Once on land, the blocks were moved using wooden sledges. AI research supports the idea that workers lubricated the sand with water or other substances to reduce friction, making it easier to drag the heavy loads. This technique was surprisingly effective and resource efficient. It meant fewer workers were needed for transportation, freeing up labor for other tasks. Speaking of labor, the workforce behind the pyramid was enormous. Estimates suggest that several thousand workers were involved, but rather than a chaotic mob, it was a well-organized system. The AI studies reveal that workers were divided into specialized teams, each with clearly defined roles: quarrying, transport, stone cutting, and assembly. This division of labor was critical. Quarry workers focused solely on extracting the right-sized stones, while transport teams ensured steady movement of materials. Craftsmen in stone-cutting workshops shaped and prepared blocks off-site to precise specifications. This pre-planning minimized delays and errors during assembly. Managing such a workforce required an impressive support system. Worker villages near the site provided housing, food, medical care, and tools. Archaeological evidence shows bakeries, breweries, and even hospitals, which suggest the state invested in worker welfare to maintain productivity. The presence of well-fed, healthy workers contradicts the outdated image of slaves forced to toil under brutal conditions. AI's analysis of artifact distribution around the site also points to sophisticated scheduling and supply chain management. Materials like copper tools, ropes, and wooden sledges were stockpiled strategically to avoid construction bottlenecks. Seasonal considerations were factored in too. During the Nile's inundation, many workers focused on quarrying or tool production, shifting construction work to drier months. The pyramid's modular design also played a part in logistics. By building in stepped layers, construction teams could work on different sections independently, allowing parallel workflows and reducing downtime. This meant that while one team finished cutting stones for the upper layers, another could be assembling lower levels. Lastly, AI helped uncover how labor was likely rotated. Teams worked in shifts to keep progress steady without exhausting workers. Rotational systems also helped maintain morale and reduce injuries, important factors in a massive, multi-year project. All of this points to a remarkable feat of project management that rivaled modern construction efforts. The Step Pyramid's builders combined efficient resource allocation, worker organization, and innovative transportation techniques to make something extraordinary possible. Without this logistical backbone, even the cleverest engineering ideas wouldn't have worked. Understanding these behind-the-scenes efforts gives us a much clearer picture of the scale and sophistication of ancient Egyptian civilization. Implications of the findings. The revelation that the Step Pyramid of Djoser may have been constructed using an advanced hydraulic lift system is more than just an intriguing theory. It's a game-changer for our understanding of ancient Egyptian engineering and society. This discovery doesn't merely add a new layer to the pyramid puzzle, it reshapes the entire picture. For centuries, the prevailing belief was that the Egyptians relied on massive ramps and brute force to build their monumental structures. While these methods certainly played a role, the hydraulic lift theory introduces a level of sophistication previously unimagined. If ancient Egyptians harnessed water pressure to elevate heavy stones, it suggests a deep understanding of fluid dynamics and mechanical principles, concepts that were thought to be developed millennia later. This insight challenges our assumptions about the technological capabilities of ancient civilizations. It prompts us to reconsider what other advanced techniques they might have employed, hidden beneath the sands of time. Constructing such a complex hydraulic system would have required meticulous planning and coordination. The logistics of sourcing materials, managing labor, and maintaining the infrastructure point to a highly organized society. This discovery offers a window into the administrative prowess of the Third Dynasty, highlighting a level of bureaucratic sophistication that was essential for executing large-scale projects. The presence of specialized labor divisions, as indicated by AI analyses, further underscores the complexity of the workforce. These weren't just groups of unskilled laborers, they were trained specialists working in harmony, each contributing their expertise to the project. The hydraulic lift theory also provides clues about the environmental conditions of ancient Egypt. The existence of a functioning hydraulic system implies a reliable water source, likely from the Abusir Wadi. This suggests that the region experienced wetter conditions during the Third Dynasty, supporting the idea that the climate was more favorable for such engineering feats than it is today. Understanding the climatic context is crucial, as it helps explain how the Egyptians could have sustained such large-scale projects. It also raises questions about how environmental changes over time may have influenced architectural practices and the eventual decline of certain construction methods. If the Step Pyramid was indeed built using a hydraulic system, it represents a significant leap in architectural innovation. This challenges the traditional narrative of pyramid evolution, which posits a gradual progression from simple mastabas to the more complex pyramids of the Fourth Dynasty. The introduction of hydraulic technology could have accelerated architectural advancements, leading to more ambitious projects. It also suggests that subsequent pyramid builders may have had access to a different set of tools and techniques, influencing their design and construction methods. The ingenuity of ancient Egyptian engineers offers valuable lessons for contemporary society. Their ability to solve complex problems with available resources demonstrates creativity and resourcefulness. In an era where sustainability and efficiency are paramount, looking back at ancient solutions can inspire modern innovations. For instance, the principles behind the hydraulic lift system could inform current engineering practices, particularly in areas where traditional methods are less feasible. By studying ancient technologies, we can discover timeless solutions to modern challenges. The allure of Egypt's pyramids transcends time and culture. These monumental structures, rising from the desert sands, have captivated imaginations for millennia. But what fuels this enduring fascination? Humanity's enduring fascination with the pyramids. At their core, pyramids are symbols of human ambition and ingenuity. Constructed with precision and purpose, they stand as testaments to the ancient Egyptians' advanced understanding of mathematics, astronomy, and engineering. The Great Pyramid of Giza, for instance, was the tallest man-made structure for over 3,800 years, showcasing architectural prowess that continues to inspire awe. Beyond their architectural feats, pyramids are steeped in mystery and symbolism. They were designed as gateways to the afterlife, reflecting the Egyptians' complex religious beliefs and their desire for immortality. This spiritual significance adds layers of intrigue, prompting questions about ancient rituals, beliefs, and the afterlife. The pyramids also serve as cultural icons, representing the zenith of ancient Egyptian civilization. They embody the power and grandeur of the pharaohs, offering a glimpse into a world of opulence and divine rule. This connection to a bygone era of prosperity and mystery fuels our collective imagination. In modern times, the pyramids have permeated popular culture, appearing in films, literature, and art. They are often depicted as settings for adventure and discovery, further embedding them into the global consciousness. In essence, humanity's obsession with the pyramids stems from their embodiment of human achievement, mystery, and cultural legacy. They invite us to ponder the past, explore the unknown, and reflect on our own aspirations and beliefs. Against all assumptions, AI has finally solved how Egyptians built their first pyramid. And the truth is far more ingenious than brute force. Rather than relying solely on massive ramps or manpower, the Step Pyramid rose through spiraling ramp networks, sledge lubrication, lever-assisted precision, and team-based logistics, all revealed through modern analysis. This redefined narrative upends centuries-old myths and serves as a powerful reminder. Ancient engineers weren't just strong, they were strategic visionaries. What you think you know about the Step Pyramid's construction? Think again. Thanks for watching the video.